Good afternoon, sir. Myself, Sir Kumar. My registration number is 19MS1051. Today, my topic is cost benefit analysis. About cost benefit analysis, cost benefit analysis measures a project's sociable value by quantifying the project's society effects and the making costs and benefits comparable in monetary terms. CBA is the most widely applied tool for the appraisal of transport projects. This chapter aims to provide to up-to date and overview of recent literature regarding the applications and the development of CBA in the context of transport policy and planning. We describe the history of CBA and its foundations in the welfare economics. We review literature on recent developers and debates regarding the method as well as the literature on implementation of CBA in practice. In CBA is often used when considering investment decision both by firms and governments. Typically, firms will look mainly at their own costs and benefits, while government decision may consider provide and negative effects for many people and firms in the education. Because of this broad scope, cost benefit analysis for government decisions is often called as social benefit cost analysis. And in cost benefit and analysis, there are three decisive cost benefit indicators. Cost benefit analysis is generally based on the three decisive indicators. First one is the net present value, and second one is the economic rate of return, and the third one is the benefit cost ratio. Each of these three indicators assesses the viability of the project, and combined they provide a realistic picture of the IPF. It would be therefore be advisable to include all the three in the cost benefit analysis of safer school project. And net present value, the net present value is the present value discontinued to present times minutes and cost of investigation, and defining the discount rate and time frame and a critical when expressing future benefits in monetary terms. The further into the future benefits, like the higher the effect of the discount rate expression will be. Appropriate discount rates could be determined by following standards published by the World Bank of IPF discount rates, and horizon of 25 years for retrofitted and 50 years for replaced school buildings in order to for safer school IPF to be viable, and net present value should be positive and higher the better. Net present value, this is the formula of net present value. And economic rate of return, ERR. The ERR is the rate of which the net present value is equal to zero. In other words, the ERR is the discount rate at which safer school IPF would be viable, and the ERR can be determined by setting the NPV 0 and solving for the ERR. Similarly to the net present value, the higher the ERR, the more desirable a safer school IPF will be, as it signifies high return on the IPF. Net present value equal to 0 equal to sigma benefit cost by 1 plus ERR power n. And benefit cost ratio, BCR. The benefit cost ratio is the net present value of the divided the net present value of costs. This is allows for a direct comparison between the benefits and cost of the benefits of the higher the benefit cost ratio, the better, and the minimum it should be above 1.0, and any ratio below 1.0 indicates that IPF costs outweigh the risk reduction and functional benefits of the IPF. Benefit minus cost ratio equal to net present value of benefits by net present value of costs. And the losses and benefits impact analysis, and the decisions on the line of intervention will be based on the engineering analysis. At the analysis that task teams may only have an estimate to split between different inventions option, such as retrofitting and replacement, and This means that the cost for retrofitting a school should be between 45 to 60% of what it would cost to be rebuilt the same school following the exact threshold depends on the government policies and the time frame in the cost benefit analysis should be chosen for the interventions, right? Life cycles may differ. For instance, retrofitting school buildings can be expected to have a shorter lifespan that replaced ones, and therefore it is advisable to separate them into two different categories. Uh, Two different categories in the calculations. The framework of the cost benefit analysis under ERIK assigned a framework time frame of 25 years to retrofitted and 50 years to placed school buildings. Cost efficiency ratio equal to intervention cost IC by replacement value RB and calculating costs. In many cases, the cost of intervention will be equal to the investment funds of the safer school investment of the IPF. Ideally, the cost would be based on the exact intervention cost based on the selected schools. However, as this is generally not possible in an ex ante cost benefit analysis, the costs can be considered the investment amount and in the first year 25% in the second and the remaining 25% in the third year and of IPF. This assumption would be important in the calculations of the project's net present value and economic rate of return. In case of uncertainty, it may be advisable to assume that all funds will be spent in the first year, which would produce a more conservative estimate. Estimating benefits. A safer school project is expected to offer benefits in the following ways. Avoided damage to buildings, functions such as upgrades of water, sanitation, hygienic facilities, and improve energy efficiency and additional benefits to avoided. And benefits equal to sigma damage due to the earthquake out intervention minus damage with intervention. And avoid fatalities. To estimate the avoid fatalities, the following factors and key and location and magnitude and earthquake risk, number of schools to be intervened, and schools occupancy 3 rates and crowding 4 rates of schools. And as the group of selected schools is likely unknown at the time of complex cost benefit analysis, and one key step in the cost benefit analysis involves establishing a monetary value for the fatalities and first in country survey could be conducted of IPF as certain the willingness to pay to prevent the loss of life and reflecting the intrinsic value of life and as the highest benefit usually stem from lives saved. It is important to discuss the VSL with the government counterparts as quantifying the value of life can be sensitive topic in some countries. Avoiding economic damage in general, avoided economic damage centers avoid direct damage to building and assessed value of infrastructure and distributions of for future economic activities. The increase in asset value is defined as the difference of asset values expressed in terms of pre-intervention values and post-intervention building valuation. There are different methods on estimating the avoided direct damage to school buildings and asset values. And benefits of functional improvements such as for high instance energy efficiency wash upgrades can be also considered as the cost benefit analysis. And to increase the in health and welfare benefits remains difficulty to quantify. A study conducted by UNICEF lists water and sanitation facility as the ingredients, public health of the students, and links the spread of diseases to in adequate WASP facilities. Benefits due to improvements of WASP facilities are expected to be based on the health improvements as the spread of diseases is curbed. Example diarrhea. In addition, the construction of new WASP facilities or improvement of old ones can lead to a reduction in days of schools missed by girls due to menstruation. And the benefit cost ratio would be understood due to unobservable welfare benefits. And thank you.